and talking about them. And this is not really my area of expertise, kind of a lecture section here. So bear with me. I'm probably going to go off on a few tangents and maybe forget what I was talking about. But I have some pretty good questions that were submitted here from everyone else. So I'm going to do my best to stay on topic and keep you all marginally entertained. So right off the bat, I took a speech class in college, and they were like, you got to start with a hook, something to break the ice. So here's a stupid dad joke for you. How do trees log in to the internet? I ruined it. They log in. But, all right. Moving on to the stuff I'm actually better at talking about. So some of these questions that were submitted, some you could write novels on, and some are pretty easy to answer. So the more in-depth ones I'm going to save for later, just to see how much time we have left. And at any moment, if you have a question, please raise your hand. This was supposed to be a Q&A session, not an hour-long lecture. So I'm more than happy to verify or talk any more about any questions you have about what I'm spurting off at the mouth about. So the first question, how much bark can come off a tree before it dies? So it's kind of a loaded question. First, I think we need to talk about how trees are different than people. A lot of this might be a little bit of a review for what we talked about when we were on the walk. And if you weren't here, it'll be brand new information for you. But trees do not heal like people. So if you cut yourself, your cells will regenerate themselves in that same spatial location. So your cells actually regenerate and fill in the gap, and they create a scar. And trees do not work like that. So if a tree is damaged, it's pretty much going to abandon that wood and compartmentalize it. That's a big word. So the father of modern arboriculture, Alex Shigo, who passed away about 10 years ago, spent about 65 years of his life with the forest department researching how trees actually functioned. And he had large controlled studies of trees that he injured and then cut them down 15, 10, 30 years later and dissected them to see actually what was happening as the trees reacted to this damage. And he came up with the nomenclature CODIT, compartmentalization of decay in trees. And ever since then, it has changed the way arborists and the tree industry has looked at how trees are damaged. So pretty much, the tree will create 4 walls around the damage in the tree, whether it be a pruning cut, cutting a branch off, or if the bark is scuffed up by a snowplow. Pretty much, it doesn't matter where the tree is damaged. It's going to react pretty much in the same way. So it'll wall off the vascular system at the top and the bottom. That's going to be your first wall. And that happens relatively quickly. This is going to prevent the infection of pests and pathogens, mostly pathogens at this point, because pests normally come in after. They're not that fast. And then you have your radial walls, which is your second wall, which prevents the spread of decay laterally to the sides. After that, you have your third wall, which is probably one of the stronger walls, and it prevents interior decay. And then your fourth wall being your boundary wall, which is pretty much the tree, the bark, growing over that wound. So that's why you don't see wounds from 20, 30 years ago, because the tree has actually grown new wood around that section of tree. And the tree does this because it has no way to replace wood cells in a spatial location. So the only way for it to recover from that is to say, all right, this wood has been damaged. It is now exposed to oxygen, fungus, pests, pathogens, the whole world that it used to be just an interior part of its anatomy, and now it's been compromised. So what it does is there's also a chemical and a physical reaction that takes place, and it impregnates that wood with tannins and other chemicals to prevent whatever decay is going to take place in that section of the tree from spreading to the rest of the tree. If this process didn't take place, then every single time you scrape the bark off a tree, in a year, rot would kill the tree and take it over, and it would fall over. So by this happening, the trees can deal with hundreds of wounds throughout their lives and just continue to grow around them, pretty much. So to answer your question about how much bark can come off a tree before it dies, we have to kind of understand how trees react to damage. So pretty much there's photosynthate created by leaves at the top of the tree. This is these sugars and starches that are created through photosynthesis. These chemical reactions are made possible by water and nutrients that are collected from the roots. It's a two-way street. You have the vascular cambium system of your tree. Your xylem, which is more on the inside, conducts water and minerals in the water from the roots to the leaves, which are necessary for photosynthesis to take place. And then the starches and sugars created in the leaves then travel down the phloem to the roots and the rest of the tree. So, how much bark can come off a tree before it dies? Well, it depends on where that bark is coming off the tree. Consider a lightning strike, there's going to be either a very long, straight, or a slightly spiraling scar coming from the top of the tree down to the bottom of the tree. And trees can sometimes recover from this type of damage because, here's a little tangent, lightning doesn't actually enter the tree ever. Lightning is following the path of least resistance. Generally, there's a lot of water running down the tree during a lightning strike. So the reason you see the bark blowing off the side of a tree during a lightning strike is because of the supersonic boom that takes place the instant that the lightning strikes. And it's the vacuum created by the atomization of the oxygen particles in the air that literally blows the bark off the tree. The lightning rarely ever enters the tree itself. So the damage to the bark is only a couple inches wide, and the tree will then immediately start making those walls I was talking about, and then over time potentially close that wound back up. However, sometimes it can't. So that much bark coming off a tree could technically kill a tree. Sometimes it doesn't. It's really how vigorous the tree is. It's like if you're 85 years old and you get influenza, you probably don't have the best chance. If you're 25 years old and you get influenza, you probably got a pretty good chance. So trees are the same way in that aspect, that the more vigorous they are, the more capable they are at healing themselves and making it past having some pretty traumatic damage done to themselves, versus a tree that has been repeatedly abused or had its roots dug up or had fill placed all the way around its existing root system. It's probably not going to do very well after that, so its vigor goes down. So, bark. So, alternatively to that, we have a vertical bark scar like that, versus, say, in the wintertime, you might have an apple or a fruit tree that was doing super great, you loved it, and it had delicious fruit, and you wake up one spring day and all the snow is melted away and all the bark's been eaten off by a vole all the way around. I'm sure anyone that's grown a fruit tree has probably experienced this. It's very sad. So if the bark has been completely taken off all the way around the tree, it's probably going to die. 100% chance. Because that vascular system I was talking about earlier that conducts water and photosynthate up and down the tree has been severed completely at that point. So it's pretty much just starving of thirst at that point because it can't conduct photosynthate or minerals or water, and it will die. I have seen apple trees last 2 years being girdled. They flower beautifully, but they're pretty much just living off of starch reserves in in their cells. But after that, they don't make it. You can do certain things like try a bridge graft, so you can take, depending on how long the bark has been taken off, you can try things like bridge grafting. So you take like a year of growth off the tree, one stem, and then you take an X-Acto knife and you cut both ends, and you literally make two little slices into the bark above and below, and you slide it in, use grafting tape, you put like 5 or 6 of these bridge grafts in hopes that potentially you will recreate that vascular system that was destroyed. I've tried it 3 times, all 3 have failed. I am not that good at it, but with practice comes perfection. I do know some grafters that have had a lot of success with it. It's a lot easier if the entire bark hasn't been girdled all the way around it. So that was one question. Lots of tangents. Any questions on that? If I use any words you don't understand too, just raise your hand. Let's make this interactive. Is there a simple way to tell tree species apart by looking at their bark? Simple is objective, I guess. Everything's simple if you know how to do it. If you don't, then it can be very difficult. With practice comes perfection, again. But even I get stumped often on this. Your tree identification is about not just bark, it's about bark, leaf, bud, place, environment, where it's growing. Bark can be a very easily used identifying factor in trees. Like for example, obviously, a white birch versus a shagbark hickory. Like those are pretty telltale, pretty easy after you've been shown them. Like obviously, if you've grown up in Colorado and you came out here, there's a lot of trees around here. In Colorado, there's like 15 different trees. So hard telling, not knowing. You just, after you've been shown, if you can remember, it can be easy. But even I forget sometimes, and I have to look up or look at the leaves or look at the buds to try and tell. I mean, even with ash trees, there's 2 different species of ash trees in Maine, white and yellow. And I've given up trying to identify the difference between the 2 of them because they're pretty much the same wood. Mills look at them as both ash. They're only differentiated in like your dendrology classes, which is the study of the identification of trees. So, I mean, ash trees, they all have this diamond-plated bark. And I think white ash has 7 to 9 leaflets, and green has 7 to 11 leaflets. And the bark pattern on white ash is a little bit tighter, and that's about it. But it differs. Like, if they're both right next to each other, yeah, you could probably tell them apart, but they rarely are because they have 2 different growth habits. Your white ash likes a little bit more of a wet area. The best way to tell those 2 apart is in the fall, because your white ash is going to turn purple when the foliage comes out, and your green ash will turn yellow.
Eli.
Yeah.
Why is ash bark so corky?
Evolution. For some reason, during differentiation, it decided that there was some benefit to having it be corky. Just like, why are there cork oak trees in England or in the Amazon? It's just the way it is, I guess is my answer. I wish I had a better one for you. I could, again, if there's any questions that I am stumped on, I will tell you. I don't know, instead of trying to pretend I do know. But if you really are interested, I'll have some business cards out with my email address on it. You can shoot me an email, and I'll try to put a little bit more effort in for you, or at least point you in the direction of some references that might point you in the right direction. All right. Can trees feel pain? I mean, from a spiritual standpoint, I would definitely say yes. From a realistic reality, I'm probably leaning, like, from a scientific perspective, probably not. I'd kind of compare this to the Matrix movie, right? So when when Neo and Morpheus are talking about whether or not they really know what the taste of chicken is, they're eating this sludge on their Nebuchadnezzar. I'm sorry if you haven't seen this movie, but I feel like everyone should have seen this movie by now. And then the other kid's talking to him about, in the Matrix, none of them ever really had chicken. It was all the computer telling their senses in their brain that they were tasting chicken. So it's a chemical and a physical reaction to damage. Trees do not have the sensory organ, like, they don't have brains, so they don't have any way to process pain. Do they feel it on a spiritual level? Yeah, probably. Are they all connected through fungal connections and root grafts? Yeah. They definitely talk to each other, but it's more of a chemical and a physical reaction. I don't think they actually sensory feel pain. So why do hemlock scars heal in a zigzag, zipper-like form? It's a very specific one. So hemlock scars, I guess if there was a crack in a hemlock, vertically, as like a torsion crack from, say, an internal, something that happened a long time ago, when I was talking about the walls, say it got injured, something took the bark off, and then that fourth wall grew over that damage in the tree. Sometimes that decay inside the tree, with the constant blowing in the wind, can form an internal crack. And that crack can be expressed all the way through to the outside. And then year after year, that crack opens, and it heals, and opens, and heals, and opens, and heals. So it might seem like it's coming in a zigzag zipper pattern, but hemlocks are one of the only trees that when you damage them, especially if you make like a large pruning cut on a branch, you can actually count how many years ago that wound was made, just because the way the bark heals. So hemlocks are very unique. I haven't seen it on almost any other tree. So you can actually count the rings, the yearly growth rings on that fourth wall that is closing that wound over. So you can tell, you can count back from the center to the point where it has just closing. Any longer than that, you're going to lose track. But you can count how many years ago that wound took place just because of the way that that fourth boundary wall closes on a hemlock tree, which is unlike any other tree. So that, I hope that answers your question. I think it happens because, just like I said, that fourth wall, you can actually count the rings on it, which you can't really do with many other species. Are hemlocks in the Bridgeton Lovell area at risk for the hemlock woolly adelgid? I'd spoken on this a little bit at the walk. I would say no. Are they at risk? Yeah, I mean, if you were in that area and you took a clipping and you inoculated it and put it on a hemlock here, yeah, it would probably infect the tree. Would it live long enough to kill the tree? I doubt it. I think being a zone 3 here, borderline zone 4, I don't think that the hemlock woolly adelgid is adapted to live in these areas. Coastal regions where the quarantine has been upheld in the state of Maine for a couple of years now, they're zone 5 to 7. So I just don't think that we're going to see it here. I don't think it's ever going to be a problem in this area. We have had leaders of a few of our white pines die. So For those of you that don't understand, a leader is the top of a tree. Sometimes pine trees will often break into multiple leaders. This can happen for a few reasons. One of the most common is when you get pine trees like growing on this row here that have too much sun and not enough competition. They're very attractive to pine beetles. And when they get too much sun, the pine beetles actually lay eggs in the apically dominant bud at the top of the tree. And they will kill it. You often see pine trees that are growing in an open area without a lot of competition from other pine trees. Like during the walk, we were walking through and there was pine regeneration, and it's like per square foot area, there's like 30 pine trees. And that's how they're meant to regenerate. They compete for the sun and the strongest win, and that's just how it goes. And that's why you get super nice, tall, straight as an arrow pines in the middle of the woods that are extremely valuable, versus these pine trees planted along the edge here are all probably going to get weeviled. So the pine weevil will come in, and they like to lay their eggs in a very sunny pine tree, and it will kill that apically dominant bud. And what happens when the top of the pine tree dies is all 5 of the branches below it then turn vertically up. And they all compete with each other for apical dominance. So they're all trying to be the top. So when this happens, when a tree is 30 feet tall, 15 feet tall, you're going to, 100 years later, have a tree that is a single stem, and then at 30 feet it breaks into 5 stems. And then those stems grow another 110 feet tall. So you have multiple leaders on that tree. And that's one reason why you might have, why something like that might happen. Instead of just having a nice straight pine tree, you have a tree with a bunch of leaders on it. That's just how they're adapted to evolve. Adapted to evolve. Does that even make sense? So we had a few leaders. We had a leader of a few of our white pines die. Is it due to disease or pests? Are there any preventative measures that will prevent the damage? I mean, it's hard telling not knowing. I mean, I often get calls and people ask me, and it's like, I got to get eyes and boots in the ground. I got to see it to really give you a good answer to that. Is it pests or pathogens? That's 2 of 3 possible things. The third being mechanical. Some mechanical damage to it. If stems grow too closely together, like a good strong union is a Y, or a U, excuse me. You're gonna have that's gonna be our strongest union between 2 co-dominant leaders. Versus if you get 2 that look more like a V, over time those are gonna be highly likely to fail. The reason being for this is as the trees grow, you end up getting included bark coming in between those 2 stems that in a U-shaped tree, you'd be looking for a bark branch ridge. So where the 2 stems actually meet, you want a healthy, strong union. You'll actually see like a stegosaurus plating coming out vertically out of that branch union, where the bark is literally growing into itself and pushing out. So you maintain that strong wood-to-wood attachment of those 2 branches. Versus when you get a very tight union, the bark will literally grow into itself, and that's called an included branch union. And what happens is, as the tree grows bigger and bigger in diameter, and both stems grow bigger and bigger in diameter, they start pushing against each other. And that included bark, there's no real attachment between those 2 stems, because there's bark from this one and bark from this one growing into each other. So, say you have a big V like this, the only real true attachment point is going to be like a couple feet below that. Everything between these 2 sections here is included bark, so it's it's killing the cambium layer on the inside of those 2 stems, which could technically kill one of them if one of them was dominant and bigger, and just it killed enough of that second stem to compromise that second stem. That could be one way that one of your leaders could have died. Alternatively, it all comes back to tree vigor, and how vigorous the tree is and how healthy it is, really. But normal branch shedding on pine trees is completely normal. A lot of people look at a pine tree with 50 feet up, all the branches are dead. But the top of the canopy looks completely fine and healthy to me. And a lot of people are like, is my tree dying? No, your tree's not dying. Those branches were not committing, they weren't helping the tree as a whole. So they were probably shaded out, and they were no longer producing enough photosynthate to support them, that single branch itself, let alone contribute to the tree. So the tree at that point says, hey, you know what, I'm done with you. I'm going to extract all of the minerals and nutrients out of you that I can. I'm going to create those 3 boundary walls walling off this piece of dead wood, and I'm just going to forget about you and take all those minerals and nutrients and put them somewhere else in the tree that is getting more sun. So those dead branches, that's part of the natural process of the tree continuing to grow. They can't get up and walk away or move and go to a more sunny spot. Like these few people over here are now in the shade. If you wanted to, you could get up and move back into the sun. Trees can't do that, so they do the best they can with what they got. Where is the best place to buy saplings? Or is it better to transplant a local sapling? So, I mean, the best place to buy saplings, as close to your home as you can get them, for many reasons. As far as transplanting saplings from around your house is a great idea. Sometimes it's way more difficult than getting a balled and burlapped or a caged or a potted tree from the nursery. Just because those potted or balled and burlapped have been grown in that container and they're much easier to plant. Versus if you try to dig up a tree, sometimes, I mean, the roots don't always grow perfectly right where you think they are. I mean, some trees have they'll go into the ground and one whole root will go that way and then it'll spread out. And there's no roots over here. They're chasing nutrients where it's available and water where it's available. And there might have been other tree roots 20 years ago that were there that impeded them from growing into that section. So when you're digging the tree out, I mean, you could put one spade in the ground and then sever almost all the roots on it. So it's a lot more work to transplant than it is to go buy, in my opinion. But if you can pull it off, then more power to you. Go for it. The best thing you can do when you do transplant is you're going to... Generally, trees don't like send this taproot down. Like all the old diagrams about how tree roots actually grow are kind of not really accurate. 90% of the roots of a tree are generally in the top 6 to 8 inches of the soil by mass. And that's mostly because you have a lot of these fine feeder roots that by mass take up about 90% of the water-absorbing roots in the tree. Then you have your main structural roots, which provide just like that structure and, you know, keep them standing straight. But it's hard telling where those roots are actually going to be until you start digging. But the best thing you can do when you are transplanting is dig a hole just deep enough to get the root flare of the tree right in the ground, right at ground level. You don't want to plant the tree too deeply or not deep enough. There is a perfect level, depth-wise, to put a tree in the ground, and it's very obvious when someone points it out to you. The second best thing you can do is plant that digging hole twice as wide as that root ball is. So you don't just want to dig a hole straight down and plant that tree ball and burlap or right out of the pot in the ground and then fill it back in. Because the roots, especially if they've been in that pot for too long, will start to circle around that pot, which will inevitably cause girdling roots down the road as they try and grow out. So if it's really that bad, what I would do, you're loosening it up twice as far out so that the tree, when it does start to root out, it has easy soil to grow into. If you just dig a straight spade pine tree in an 80-mile-an-hour microburst wind event, it's going to fail, or it has a high likelihood of failing. As an arborist, the best thing we can do is identify trees that are more likely to fail. Otherwise, the alternative being, let's go in and cut every single pine tree around every single house within striking distance. It's all risk benefit. So by looking at the trees, if you say you had a pine tree next to your house in the water that you were worried about coming down, I would assess it and say, hey, this tree looks strong and healthy, and by topping that tree out, yeah, we're going to reduce the sale effect of that tree, but we're thinking the longevity of that tree. There's nothing in nature that really works like topping a tree. So before the advent of chainsaws, like, yeah, some trees the top will topple over, but by topping a tree, what you're inevitably doing is the tree has no good way of responding to a topping cut like that. So there are no walls created because the tree has no natural way to close that wound up. So what's going to happen is all the branches below that topping cut are going to then turn straight up. And on a mature pine tree, those branches are probably going to be 30, 40 feet long. So then you get 4 or 5, 30, 40 feet long branches that all the branches off those branches turn straight up and try to become tops themselves. So then you have a huge lever 20 years down the road. So you've created a bigger hazard because those pine branches are now going out and now they're going up. And they're going to grow extremely fast, trying to fill that void that we created by topping that tree out. So inevitably, you're creating more of a hazard than it was there originally. Alternatively, if you do have like codominant stems, there are bracing techniques, cabling systems that could be used to limit that risk, be used as kind of a safety net. But as far as just going in and topping out trees, not on mature trees. I would refuse. And anyone that would do it doesn't know what they're doing. You can train trees when they're younger. You can subordinate them, trying to get them to grow out instead of up. We do it with fruit trees all the time. It's a never-ending battle. If you want to maintain a view cut and you don't want to cut the trees down, you can keep, every 2 years, go in and keep snipping them out. And inevitably you'll get, a 30-year-old maple that becomes a 60-year-old maple that has really long branches that go out, but we've been training it its whole life to do that instead of just going out and cutting it in half. I hope that answered your question.
Any other questions? Well, I want to thank Eli for doing this.
You're welcome.
Wasn't exactly what he wanted to do, but he did it and did a great job. And we had a wonderful walk with him last week as well. I want to thank all of you again for coming. I did learn something watching tonight, and that is that we need to shift seating over this way so there's more shade from the beginning. Well, at the beginning there wasn't any shade, but yeah, we'll work on that. If you have other thoughts, please let me know. Audra's in the back with an envelope, an oversized envelope that is filled with envelopes in case you'd like to take one and make a donation. We have a poetry reading next Tuesday evening at 5:30. I'm not sure if it's going to be remote or if it's going to be in a location, but everyone is welcome to come, even if you weren't part of the poetry workshop yesterday, to come and listen to the poets or to bring a poem about nature that you really like and share that with us as well. And you have to, again, pre-register to do that, but we'd love to have you come. And next Friday morning, the 24th, we have a dawn paddle. We've never done this at 6:30 in the morning before, but if you'd like to bring your own kayak or canoe and join us, we are going to limit the number of that, so it's only going to be about 10 people. But again, you have to let me know if you'd like to come by pre-registering. That's how it's going to go this summer. As you are leaving, please be mindful. We tried to stagger you parking on the way in so you weren't getting out next to each other. So please be mindful as you go. And if you have any suggestions to make this format work better, let me know, because you are my guinea pigs. So, and I thank you for coming and having fun.
We did it!
So, a lot of times when you do water the tree, the water will fill that hole and it'll get too much water, or those roots won't be able to break through that hard panned, hard packed soil. So pretty much you want to do everything you can in your power to make this stressful life event for the tree you're trying to love for the next however long you can make it last. You're trying to make that transplant as easy for it as possible. So dig the hole twice as wide, plant it at the right depth. Pretty much the stem is going to come down in a straight line and then it's going to flare out. You want it to be, the soil to come right like half an inch below where it starts to flare out. And then don't pound mulch right up against the stem of the tree, because that's just going to attract voles and insects. You do want to put, 4 to 5 inches of mulch over the newly planted tree, because that's going to help with water retention. And it's also going to provide organic material as that breaks down to feed the tree over the next 5 or 6 years. But you do not want to put the mulch right up against the stem. And then water it all the time, at least for the first month. And it should be a slow, deep water, not just like you're watering your tomatoes. Just put the hose on it on slow for like half an hour. Really get it deep down into the roots. And that's pretty much the best thing you can do for saplings. So yeah, dig them if you can. And if you want to buy them, just do a little research at the nursery. Say, hey, have these overwintered in Maine before? What's their hardiness level? A lot of people plant Japanese maples around here, and they're tolerant to like zone 6. They'll last 15 years until you get that one deep freeze and that one cold, windy day, and then it'll die. You don't generally see them last that long. No more than 30 years, I'd say, I've ever seen a Japanese maple survive around here, just because it's out of its element. No pun intended. All right. Are there certain trees that you would recommend for planting singly or in small groupings in a yard that would be helpful for the local environment? Little loaded. Define environment. I mean, are we talking like, do we want more animals to come? Do we want to see hummingbirds, or do we want to feed the deer apples? Or do we have a bank that's eroding away? In that case, plant a speckled alder, because it likes its feet wet, and it's going to help stabilize that bank. Yeah, that would be too bang for the buck, because then you're going to have more birds, and it's also going to help stabilize that bank so that you don't have erosion and lose your land. The best thing I would say is, best for the local environment, plant native trees, trees local to our area. Definitely, don't plant anything non-native invasive. Barberry was very popular a decade ago. Bradford pear. Even like Japanese knotweed. Like this evil bamboo that we see everywhere. When I was 10 years old, there wasn't any of them. And I don't know what state brought it in, but it used to be an ornamental planting. And not only is it non-native invasive, but it has, this is a term, it's escaped. So it is no longer, it's seeding, and it actually layers itself. It's super evil. I'm pretty sure all of you know, have probably seen a Japanese knotweed. It's bamboo. And it is displacing cattails and so many wetland area species. And I mean, you drive down any road for more than 10 minutes, and I guarantee you can see it. And in 25 years, it's probably going to be everywhere. So just do a little research, plant native trees. I guess if you live in the water, definitely don't plant turf. No more grass. Plant some raised garden beds. Grow some food. We don't need grass. Trees are good. Food is good. Grass that you need to fertilize and manicure next to the water, probably one of the worst things you can do for the environment around here. All right. Here's a decent one. Tree winners and losers in recent history. So, question is, in the past 150 years or so, which species in Maine have been wiped out, which have thrived, and which are in danger from insects like the emerald ash borer? So right off the bat, I mean, losers. The original loser, the OG of this game, was the American chestnut, Castanea dentata. I never really saw them growing up because they were already gone. In 1904, I did do a little research on this just to make this more entertaining for you, so I wasn't just making some of this up. American chestnut tree survived a lot of adversaries for 40 million years, and then within 40 years, it was almost completely decimated. Not fully extinct, but functionally extinct because the chestnut canker actually came over from Japan in 1904, and it was when we were trying to cultivate Japanese chestnut as an ornamental planting. And once it got here, it brought over a fungal pathogen that the American chestnut, having been completely isolated from Asia for so long, had no natural resistance to this very aggressive fungus. That both Chinese and Japanese chestnuts, they get the blight, but they are resistant. They have a natural resistance because they grew not in harmony, but for lack of a better term, in harmony with each other in their native environment for millennia. Not millennia. Hundreds of thousands of years. And the American chestnut had no natural defense to it. So within 40 years, all the chestnut trees, lining the streets and even in our forests, were died. They all died. Which pretty much, I think it was probably one of the single most ecologically damaging things that ever happened in New England, just because it was a mast tree. So not only did it have very beautiful and sought-after lumber that was rot-resistant and very useful for many, many things, it was also a food source. So, roasting chestnuts on the open fire. I never did that because we never had chestnuts. But as a food source for animals, I would say, yeah, it definitely changed our forests big time. When I was growing up, there weren't very many turkeys, and I think maybe that might have had something to do with it. Probably also land use practices for us as well, human beings. But without that food source, some other tree had to come in and take over, which was pretty much the oaks, I would say. Kind of filled in that niche that the chestnut used to hold. And I don't know if anyone's tried to eat an acorn, but they suck. So, bummer for the chestnut.
So, Eli, let me just interject here. We had chestnut trees on Greater Lovell Land Trust property until about 3 or 4 years ago, and they've died. The tallest tree is here in Lovell,
Yep.
and it's still living and viable. but the land trust was contacted a couple of weeks ago, and Audra can speak to this better than I can, but by a guy from the Maine chapter of the American Chestnut Foundation, and they've planted saplings at 2 of our properties. The conditions had to be just right, so.
That's fantastic. Did everyone hear what she had to say?
Yeah.
Awesome, so I don't have to repeat it. Well, that's very cool.
Yeah.
I'm hoping, yeah, I mean, it's going to take decades to get chestnut back, but there is the American Chestnut Foundation, which is nationwide, and then there's also, obviously, divisions of that state to state. And I know they're doing some back crossing work, trying to back cross American chestnut with your Japanese and your Chinese chestnut, which have a natural resistance. And last I checked, they were in like their 11th or 12th generation of back crossing. So they're trying to maintain, like 80% of the genetic makeup of the American chestnut and back cross just the resistance out of the Chinese chestnut and into the American chestnut, which is a very time-consuming process. But it would be very cool if they did figure it out and then they were actually not sterile and they actually produced their own seeds, at which point we could then start replanting them. Yep.
Can you hold the microphone?
Can I hold it closer? Yeah,
Just
sorry.
closer to your mouth?
Did you hear what I just said?
Thank you. Almost.
Almost?
Yeah.
So there has been a back crossing process with Chinese and Japanese chestnut with American chestnut. I think it's on like its 12th generation to get the genetic resistance to the chestnut blight transferred into the American chestnut, at which point we would be able to plant them in the woods and hopefully have them be non-sterile and produce their own seed crops. So we could reforest with American chestnut, which would be super duper awesome. Another loser, American elm, very similar to the chestnut in what happened in 1940. It was believed that beetles arrived on a shipment of logs from the Netherlands, hence the disease became known as the Dutch elm disease. Yeah, he was there. They're losers. American elm. Well, you do see them a lot, but they never grow to the full size. I mean, they do. You do see big elms, but not as big as they used to be. Generally, you'll see. Yep, go ahead.
I was just gonna say that I know there's a few islands out in Maine that have full ones because they've been isolated from that.
Well, that makes complete sense. Yeah, she had just said that she knows that there are a few islands in Maine that have large elm trees because they've been isolated, which does make a whole lot of sense. Next on the list is probably going to be our white and green ash. We do have another non-native pest called emerald ash borer. Let's see, do I have any info on this? Yeah. It was discovered in Detroit in 2002, and it is believed to have entered the country on wooden packing materials from China. Again, non-native, it came from China, and it's a very aggressive pest, and it is attracted almost entirely to ash trees. And the difference between it and most bark beetles is it will actively kill a healthy, vigorous tree. So when trees get damaged or become less vigorous, they actually release pheromones and chemicals that obviously we as humans can't really see or taste or smell, but those pheromones are very attractive to insects. So that's why most native bark beetles are going to go after trees that are already either dead or very close to death because they're easier to attack. Whereas a vigorous tree, the second that beetle bores into the tree has all these chemical and physical reactions and stored energy that's going to use to expel that beetle either with resin or sap. It has a lot of natural things it can do to resist the entrance of beetles, but the emerald ash borer is super, super aggressive, and the way that they make their interior galleries, and by gallery I mean the pattern that it creates as it eats and bores through the wood, it doesn't go straight into the center of the tree and lay eggs. It actually makes these zigzagging galleries, like right at the cambial layer, which the second they start making those galleries, they will inevitably make it all the way around, and they'll girdle the tree just like that volvulus we were talking about, that apple tree in the beginning of the speech. And they'll kill the tree within a year, which, it's going to be it already is a huge deal in urban environments, because I think ash trees probably take up, 20% of urban trees along the East Coast. And I know down south where it's been much more of a problem than up here. It's a lot for municipalities and local tree guys to deal with, to take out 10,000 ash trees that died all at the same time. It is not. I think it's crossed from Canada into the northern Maine border. I think that happened last summer. I know it's in Concord, New Hampshire, so it's not very far away. It's kind of scary, but I know Maine has a lot of projects to, they're testing. They put up, the ag department is putting up these little purple traps all over the state, and that have pheromones in them to attract the emerald ash borer. Just try and make sure that these quarantines that we're putting up are working. Pretty much the best thing we can do at this point is just don't bring out-of-state firewood into the state of Maine, because it's going to hitch a ride on that. The last big loser, which isn't quite a loser yet, because we haven't seen this pest yet, but it is right up there with emerald ash borer. It's called the Asian longhorn beetle, and I got a lot of people asking me, hey, I think I have an Asian longhorn beetle. It looks very, very similar to the Maine pine borer. It's about 2.5 inches long, and it's black with white speckles all over its back with big old pincers, and you'll see it in pine all the time. Like if we're out cutting a pine stand, they're attracted to the smell of pitch. They'll fly right onto you, and they're mean pincers. Like, they don't normally go for you, but if you put a piece of wood in your pincers, they're pretty aggressive. If you ever have had a down pine tree next to your house, it's been there for a long time, the larvae of these pine borers, they actually make a pretty cool sound. It's like a whoa, 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 whoa. It's really loud. You can hear them. They're probably about 3/4 of an inch fat, and they are just mowing their way through that dead pine log to the point where you can hear them from 40, 50 feet away. The original chainsaw blade was, I think, designed between a mechanical engineer and an entomologist. Were living together or something, and this chainsaw tooth was designed from the pine sorer beetle's teeth, chompers. So that's, neat little factoid. Sidetracked. Asian longhorn beetle looks just like the pine sorer. The only difference is the antennae are going to be as long. I think they're going to be 2.5 times longer than the beetle itself on the Asian longhorn beetle, and the pattern is going to be a stark black, white, black, white, black, white, black, white, and the dots are very uniform. Whereas your pine borer beetle, it's almost like someone threw white paint at the back of their black backs. It's very irregular, the dot pattern. Asian longhorn beetle, obviously, I think it came from Asia. The common, it's not quite here yet. It's not as close as emerald ash borer. I think it's going to have a lot more trouble getting up here just because of our climate, or how cold we get up here. It's taking a lot longer to travel north than the emerald ash borer was. Emerald ash borer is also a very good flyer. They can travel pretty far distances in one generation versus the Asian longhorn beetle, not as good of a flyer, so it's going to take them quite a while longer to get here. But the common trees that they attack include birch, willow, horse chestnut, elm, maple. They're not just like the AB where they're just mostly going after one species of tree. So when they do get here and they become a problem, it's going to be a huge problem because they're going to attack almost every hardwood around. And if they can't find the one they like, they're going to go for the second one they like, all the way down to the sixth one they like. So, I mean, hopefully they don't ever get here. I think we're doing the same thing with quarantines, and I honestly don't know that much about them because I don't really deal with them, and they're not here yet. We're pretty busy climbing trees most of the time. So as far as the biggest losers, I would say, yeah, American chestnut, American elm, soon to be ash trees, and then, God, almost all of them. So let's, keep the quarantine working for all these non-native invasives, and just stop bad wood from coming from China, I guess. So second half of that question, who are the winners? Whoever's left to fill the niche, I would say, are the winners. With the American chestnut, I would say the oak tree probably won the game there as a mast tree. So, I mean, the winning section is an easier one to talk about pretty quick. Have conservation organizations that got land done anything useful with it? I would say yes. Many things. First off, there's a difference between preservation and conservation. So, preservation is pretty much, we're going to preserve this land. So, we're not going to do any cutting. We're not going to manipulate it in any way, shape, or form. We're not going to put trails in for recreation. We're going to leave it completely preserved in the way that it is right now and never touch it ever again. And there are some places in the United States that are preserved that are just like that. And then conservation is kind of a similar idea, except written when the land is conserved. There are definitely things that are outlined in the conservation plan that will be allowed. It's not a general term for conservation everywhere. It's some conservation lands will allow something that other conservation lands will not allow. So the whole point of conservation is to kind of like allow the most from the land for the most amount, like get the most out of the land for the most amount of people. So I mean, yeah, like recreation, even on the scale of commercial harvesting, like the U.S. Forest Service, the White Mountain National Forest, is harvested often through sound forestry practices. Commercial operations will come in and harvest that forest after sound forestry prescriptions have been outlined and trees are marked, and that's one use for that conservation land. And you can get the most bang for your buck out of the forest by harvesting it smartly over the course of having a plan laid out for 100 years. We're going to harvest it 4 or 5 times in these 100 years, and we're going to do X, Y, and Z. And at the end, you're going to have a beautiful, uneven-aged, mixed-stand forest, kind of resembling what would have been here, in the late 1700s. So, yeah, I would say conservation organizations have definitely done a lot of useful, good things for the forests in Maine and throughout the country. Whereas, cleaner air, water, wildlife habitat, there's a massive benefit to the conservation movement. I guess one way to look at it is I have a poster hanging up in my house, and it's, we did not inherit the world from our ancestors, but we borrow it from our children, kind of ideal of conservationism. Let's protect this area and not just, rape and pillage. I hope that answered that question. Have we achieved any equilibrium between conservation of the forest and using the forest to support a northern economy? I mean, I was kind of touching on that earlier, or just 2 seconds ago. I would say, yeah, there's an implied equilibrium at the basis of all conservation efforts. Like I was saying, the U.S. forest lands are cut continually, but a lot of the major land holdings in the state of Maine were owned by paper and pulp companies, all commercial lands up north that did fuel our economy. And I think, over the past 120 years, the idea of forestry and the idea of silviculture, which is learning how forests regenerate and how to prescribe cutting methods in a forest to promote different types of regeneration to try and get a forest to come back the way that you want it to. And there's been a lot of study, both here and Germany, Austria. A lot of work has been put into figuring out how to properly manage these forests so that, we're not just going in and clear cutting or going in and high grading, which is just, like a diameter limit cut where you go in and just cut everything over 26 inches. Yeah, it's the most bang for your buck at a short amount of time. But if you're going in and you're cutting all the nicest trees down and leaving all the crap trees, what do you think is going to regenerate that forest? All the crap trees. So, I mean, every tree has its own genetics, and its own seeds are going to carry that genetics with it. So if you go in and you cut all the nicest trees in the forest, there's no good, nice trees left to regenerate that forest. So, good forestry practices take that into account, and over time, we can have both a healthy forest environment where we can have recreational activities, clean water, cleaner air, better fish habitat, better wildlife habitat, and also maintain a high profit from timber harvest at the same time, instead of just going in and cutting everything with no real plan into the future. Yeah, I think that answers that one. How are we doing on time?
It's time to be done.
Oh, really? Oh,
Are you just getting into
that was only my first page.
Yeah.
All right, well, I guess that's it.
Well,
Any questions?
Yeah. Does anyone have any other questions for Eli?
I think I got to most of the ones. I think that you had given me some guiding questions, which I had done some work on, but
Hadley has
it's
a
okay.
question.
We got to the fun ones.
Can I repeat?
Hadley.
What's up?
Can you repeat what happens with lightning and
Sure.
the vacuum and blowing off the bark? Can you just repeat that?
Yeah. See, as an arborist, I work mostly with individual trees, and my background is forestry, right? So it's the study of landscape environments and trees as a full community. But I veered away from forestry quite a long time ago, and I just got into individual anatomy of trees and how to do proper pruning cuts and how trees are going to respond individually. So this is right up my alley. I love these kind of questions. So pretty much what happens, lightning is going to follow the path of least resistance, right? So water is a very good conductor of electricity. Generally, when trees get struck by lightning, they're at the eye of the storm. So there's going to be a lot of water flowing down these trees. So if you were to look at a lightning strike in a torrential downpour after it's already happened, the water's probably going to be running right down it. So think about the top of the tree gets hit. There's water running down that stem to ground, that's what electricity wants to do. It wants to find ground. So what happens is when the lightning actually strikes in that one instant, the path of least resistance is the stream of water from the top of the tree to the ground. And in the instant that the lightning strikes, it creates a sonic boom, creates a vacuum. So it atomizes all the particles in the air. And the sound of thunder is what you hear when the air that has been atomized rushes back into that vacuum. That is that sonic boom. So the lightning strike actually takes place right along the water line on the edge of the bark. And that the bark blows off from the force of the air rushing to fill in the vacuum that the electricity made by atomizing all the particles in that spatial location. Does that make sense?
That is so cool.
Yeah, it's pretty awesome.
Whoa.
No problem.
Any other? There's one over there.
Over here.
What's up?
With climate change, the severity of storms,